You walk into the local auto parts store, grab 5 quarts of the exact synthetic oil printed right there on your oil filler cap, head home, and pour it into your engine. You probably feel pretty good about yourself, thinking you are following the manufacturer's directions to the letter and doing the absolute best thing for your vehicle. But what if I told you that the engineers who actually designed and built that motor did not want you to use that specific oil? What if the federal government essentially forced their hand? Today we are going to look at the massive gap between what keeps your engine alive for 400,000 miles and what keeps automakers out of trouble with federal regulators. We are also going to look at some critical mistakes people make right after an oil change that can completely destroy an engine in under 60 seconds. Let us start with the biggest open secret in the automotive industry right now, and that is the aggressive push toward incredibly thin motor oils. If you look at almost any modern vehicle sold in the United States today, the oil cap probably says 0W20, and some newer models are even pushing 0W16. Most drivers assume this is because modern engines are built with incredibly tight, microscopic tolerances, and they physically require a super thin oil to function properly. That is not the whole truth. The primary reason you see 0W20 specified on your engine bay is because of corporate average fuel economy, or CAFE standards. Automakers are under intense pressure from the federal government to meet incredibly strict fuel efficiency targets across their entire fleet of vehicles. If they miss these MPG targets by even a tiny fraction, they face massive fines that can easily run into the millions of dollars. To avoid these penalties, engineers look for every single possible way to reduce internal engine friction. And the easiest way to do that is by specifying water-thin motor oil. Moving a specific engine platform from a 5W30 oil down to a 0W20 might only improve the measured fuel economy by half a mile per gallon. For the average driver, that microscopic gain is completely unnoticeable at the gas pump. But for the manufacturer, across hundreds of thousands of vehicles, it is exactly what they need to pass the certification test. The problem is that this regulatory compliance comes at a direct cost to your engine's long-term durability. That thin 0W20 oil simply provides a much thinner protective film between the rapidly moving metal components inside your engine block. If you are sitting in brutal stop-and-go traffic on a 95-degree Fahrenheit afternoon, or if you are towing a heavy load up a steep grade, that thin oil is going to shear down and lose its viscosity much faster than a thicker oil would. When the oil shears and the protective film breaks, your main bearings, camshaft lobes, and piston rings are suddenly left highly vulnerable to direct metal-on-metal contact. You can actually see this exact dynamic play out if you look at how automakers treat the exact same cars in different global markets. Take a standard naturally aspirated 4-cylinder engine from a major Japanese brand. In the United States market, the owner's manual will absolutely insist that you must use 0W20 for optimal performance. But if you take that exact same car with the exact same engine tolerances and look at the owner's manual in Australia or certain parts of Europe, you will see the manufacturer specifically recommends 5W30 or even 5W40 oil for heavy-duty use and longevity. The engine did not magically change. The only thing that changed were the local regulations. Those other markets prioritize long-term mechanical durability over a tiny fraction of a mile per gallon, so they recommend the oil that actually protects the metal. If you are getting some solid, practical value out of this mechanical breakdown and want to keep learning how to actually protect your vehicle without relying on watered-down dealership advice, take a quick second to hit that subscribe button. It really helps keep these garage sessions going. Now, let us talk about what those numbers on the plastic bottle actually mean, because understanding this is the key to choosing the right protection for your specific driving habits. A lot of people think the W in 0W20 stands for weight, but it actually stands for winter. The first number describes how the oil behaves when the engine is completely cold. A 0W oil is fantastic for freezing climates, because it remains very fluid at low temperatures. When you start your car on a frigid morning, that thin oil is picked up by the oil pump and circulated to the top of the cylinder head almost instantly, which drastically reduces the wear that occurs during those first few critical seconds of a cold start. The second number, the 20, represents the oil's kinematic viscosity, or its actual thickness, when the engine reaches its full operating temperature. This is where the protection really matters. A 5W30 oil is slightly thicker when cold, but once the engine is hot, it provides a significantly more robust, stable, and heat-resistant fluid film than the 0W20. We actually saw this proven in a massive real-world test utilizing a modern direct-injected engine. The vehicle was driven on the exact same route, with the same driver, the same high-quality oil filters, and the same fuel. The only variable was the oil in the crankcase. They ran 0W20, then 5W30, and finally 5W40, each for exactly 7,500 miles. The laboratory-used oil analysis results were clear. Even though the manufacturer fully approved the 0W20, the engine ran hotter, and the lab found significantly higher levels of wear metals, like iron and aluminum, suspended in the drained oil. The thicker oils provided vastly superior protection over the long haul. Beyond just choosing the right viscosity, one of the biggest upgrades you can make to your oil system is something most people never even think about, and that is the oil filter's internal construction. You can buy the most expensive synthetic oil on the market, but if you screw on a cheap $3 paper filter, you are shooting yourself in the foot. Inside a high-quality oil filter is a component called the anti-drainback valve. Usually, it is a premium silicone flap. When you turn your engine off, this valve traps the oil inside the upper half of the engine and inside the filter itself. When you use a cheap filter with a stiff, low-quality rubber valve, that valve often fails or warps. This allows all the oil to drain completely out of the engine block and back down into the oil pan while the car sits overnight. The next morning, when you turn the key, your oil pump has to suck up the oil from the pan and push it all the way back to the top of the engine. For those 2 or 3 seconds, your engine is running completely dry. You will hear a loud, nasty, metallic clattering sound. Doing this every single morning will absolutely destroy your timing chain tensioners and camshaft bearings. Always spend the extra few dollars for a premium filter with a true silicone anti-drainback valve. And speaking of the filter, there is a crucial step during the installation process that completely separates the professionals from the amateur driveway mechanics. Before you take that brand new filter and spin it onto the engine block, you need to pre-fill it with fresh oil. Take your new bottle and slowly pour oil directly into the center hole of the filter until the internal media is fully saturated. A dry oil filter is essentially a massive air pocket. If you install it completely dry, the moment you start the engine, the oil pump has to spend valuable seconds pushing all that trapped air out of the way before it can actually start moving liquid lubricant to the engine bearings. By pre-filling the filter, you are priming the system and guaranteeing that your engine gets immediate oil pressure the second it fires up. It is a tiny extra step that costs you absolutely nothing, but adds years of life to your internal components. Before we get into the absolute most catastrophic mistake you can make right after finishing an oil change, the one that will literally send your entire engine block to the scrapyard in under a minute, make sure you smash that subscribe button. We are constantly breaking down the real mechanics of car care here, and you do not want to miss the next session. Alright, you have drained the old oil, swapped the filter, poured in the correct amount of fresh synthetic, and lowered the car off the jack stands. You get into the driver's seat, turn the key, and immediately rev the engine up to 3,000 or 4,000 RPM just to hear it purr. This is an absolutely fatal mistake. Modern vehicle oil pumps flow an incredibly high volume of fluid under immense pressure. When you first start the engine after a service, you have not yet verified the physical integrity of the system. If you accidentally left the old rubber gasket stuck to the engine block and screwed the new filter on top of it, creating a double gasket situation, or if you simply forgot to fully tighten the drain plug on the oil pan, that high-pressure system will violently blow out its seal. At a high RPM, your engine will literally pump its entire 5 or 6 quart oil supply out onto the driveway in less than 30 seconds. Without lubrication, the internal temperatures will skyrocket instantly. The bearings will seize to the crankshaft, and the motor is completely dead. The only correct way to finish an oil change is to start the engine and let it sit at a dead idle. Do not touch the gas pedal. Immediately get down on the ground, look underneath the front bumper with a flashlight, and actively stare at the oil filter housing and the drain plug. You are looking for any steady drips or sudden sprays of fluid. If everything remains completely bone dry after a minute of idling under normal pressure, then, and only then, is the vehicle safe to drive. Finally, if you want to take your engine protection to the absolute maximum level, consider replacing your standard factory drain plug with a high-quality magnetic oil drain plug. As your engine runs, even under normal perfect conditions, the constant friction between the piston rings and the cylinder walls creates microscopic iron and steel particles. These particles are often so incredibly small that they pass right through the microscopic pores of your oil filter media and continue circulating through the engine, acting like a liquid sandpaper that slowly accelerates the wear on your bearings. A standard steel drain plug simply acts as a cork to keep the oil from falling out. But a specialized plug equipped with a high-strength neodymium magnet will actively pull those tiny ferrous metal shavings straight out of the flowing oil and trap them permanently against the base of the plug. When you do your next oil change and pull that plug out, you will see a thick, dark grey sludge stuck to the magnet. Wiping that abrasive sludge off with a shop towel and realizing that all that metal was permanently removed from your oil supply is one of the most satisfying feelings in the world. It is a simple $10 upgrade that actively cleans your oil every single second the engine is running. Taking care of your engine is not just about blindly following the numbers printed on a plastic cap. It is about understanding the mechanical realities of heat, friction, and fluid dynamics, and knowing the difference between government fuel regulations and actual engine longevity. Make sure you are using an oil viscosity that actually matches the climate you live in and the way you actually drive. Spend the few extra dollars on a premium oil filter with a solid silicone valve to prevent those nasty dry starts. Always pre-fill that filter to keep the system primed, and never, Ever rev a freshly serviced engine until you have visually confirmed there are no high-pressure leaks underneath? I want to hear from you guys now. Head down into the comments section and tell me what specific oil weight you are running in your current daily driver, and let me know how many miles you have managed to put on the odometer using that setup. Let us get a solid mechanical conversation going down there and help each other figure out the best combinations for different vehicle platforms. And if you picked up some useful, real-world knowledge from this video today, make sure you hit that subscribe button, give the video a solid thumbs up, and I will see you all in the next garage session. Keep those wrenches turning and stay safe out on the road.